There. Oh, yes, compressed. Okay, it's out of here. Okay, bam. Okay, class, let's go with it here. So, inverse functions. So, very, very important words here. Ready? What do we have to do to the regular sine function so that the inverse is also a function? We got to chop it. We chopped it down so that it is from negative pi over 2 to pi over 2. Is that right? That's the chop that we have to make. Otherwise, we can have an inverse. It just itself won't be a function. That's the problem. We're good? But we're trying to make it a function. So now, if we convert this back into the unit circle, this would be anything from 0 to pi over 2 along a unit circle is quadrant 1. Is that right? And anything from, oh, this is weird, anything from 0 back to a negative pi over 2, that would be in quadrant 4. The only weird thing is, what's the weird thing about quadrant 4 this time? Because we are not going forward, right? So this would be like 0, right? This would be up to pi over 2, right? Or 90 degrees, right? But if you go backwards this way, this is no longer quadrant 4 like we know it. It is the negative values. So instead of being 330 degrees, it is just negative 30 degrees. We're good? Instead of instead of positive 315 is negative 45 degrees and negative 60 degrees and negative 90 degrees. Good there.
Is it right to say that for the inverse function to be a function, you need the domain to be quadrant 4 to quadrant 1 of the circle?
As long as you know that quadrant 4 is a negative function, negative quadrant in a sense, not the regular quadrant 4 as we know it. Okay, so then we go radian measurement. Let's do this one. So instead of pi over 6, whoa, that was weird. Okay, pi over 6, pi over 4, pi over 3, and pi over 2, we're going backwards negatively. So this would be, instead of negative 30 degrees, it's negative pi over 6. This would be negative pi over 4. And write this in if you didn't do it last time here. Negative pi over 3 and negative pi over 2. We good? So we say the inverse function of sine functions only in quadrants 1 and 4, but it's like a negative quadrant 4. We good? That's kind of what. Okay. So just kind of speeding us up on things here. So I'm gonna go like this. Let's just do a few here in our mind, just to make sure that we can do it together. Just the first one. I think these are notes from last time. We're just kind of getting things situated here. Just do the first one for me here. All yours here. So look at the unit circle. You are in quadrant 4, but it's the negative quadrant 4. And tell me in degrees, what is sine inverse of root 3 over 2? Hmm.
Negative degrees.
Say this again.
Negative 90 degrees. Oh, wait.
In degrees, right? Ooh, sorry guys, I messed you guys up here. So I said negative, right? So sine inverse of a positive root 3 over 2. 60 degrees. We're in quadrant 1, is that right? We're in quadrant 1 because we have a positive value. Anytime we have negative values inside here, you know you're going to be quadrant 1. If you have positive values, anytime you have positive values, right, you're in quadrant 1. Anytime you have negative values, you're in quadrant 4. The negative quadrant 4.
Isn't that the regular sign of tools?
Well,
Remember, inverse means, yeah, inverse, we're just going backwards. We're going from the y value back to your angle measurement. As opposed to the sine value takes your angle measurement and gives you a ratio.
Sine
Right?
of 60 is root 3 over 2.
Perfect. Yeah, we can say that.
Sine inverse of root 3 over 2 is 60. I see. One goes there, the other goes back.
Sine of 60 degrees is root 3 over 2, and then we're just going backwards. Cool. All right, the next one real quick here. You didn't need, if you want to write it down, that's fine. Oh, can't do it.
90
Gave the answer away.
degrees. Not what? No.
Inverse sine of 1 is 90 degrees. Okay, I'm going to slow this down. Give that to me. In degrees.
Negative 45.
Negative 45 degrees. Are we good? Everything makes sense, yes or no? Okay. Again, these are just kind of things from Wednesday, right? Just to make sure that we're understanding stuff. Okay, so let's jam. Let's jam to cosine. So we also have to do the same thing to cosine. If we take cosine and we start crunching it down, so we pass a horizontal line test, is that right? Domain right now is from negative infinity to positive infinity. Range is from -1 to 1. And we start crunching it down. Tell me when we stop.
Stop.
Stop. Perfect. Okay, which quadrants are those? 1 and 2. Regular 1 and 2 or negative 1 and 2? Just regular. Cosine is just regular. That's cool. Okay, so if we do those, notice real quick here also, notice the graph. I'm trying to connect a few things together in your mind here. Anything that's positive for cosine will be in quadrant 1. We're good? If cosine goes negative, we are in quadrant 2. We good? Which is also our unit circle, right? Our unit circle says, uh, and real quick, I just want to show you real quick here. So there's the cosine function and there's the inverse function, right? So notice as we chop stuff down like this right here, we chop this down like that. We technically have chopped this down like this. Notice what we're trying to do is we're trying to pass a horizontal line test here. And we're trying to pass a vertical line test here. We're good? That's essentially what we're doing. And as we chop to here, let's say we chop this part right here then, right here, boom. Then we're chopping this part here. That's cool. And then we chop this part here. It's the same thing as chopping this part here. So now the question is, on our inverse function, have we passed a vertical line test now? Yeah, perfect. Now we got ourselves a function. But we're only restricted to quadrants 1 and 2. All right, let's do a few for cosine, just to get us thinking through stuff here. In degrees. Whoa, gave the answers. That's no fun. Okay. Are we okay there? Just check, just to make sure you guys got the same here. So if you look at the x value on your unit circle, look for the x value of 1/2. And as you look at it, do you get 60 degrees? And then as you go into the negatives, notice you're going past the y-axis now, right? You're going to the negatives, cosine inverse of -3/2, and you look for the angle measurement that's there. Everybody okay with 150? Gavin, okay with that? Okay. Jamming. Okay, so again, just going through the motions here. Okay. Okay, let's change it. I'm going to change it up to radian measurement. So can you give me the radian from a radian measurement perspective? Blunk, blunk. So instead of looking at degrees, all you're going to do is just look at the radian value. It is pi. We good? 180 degrees, right? We're all the way at -1. Okay. Boom. And how about this? And then how about this? Let you guys do all three real quick here. Let me walk around real quick here, see how you guys are doing. Just super fast. For some people, this would be like super easy. For others, not so super easy. Let you guys talk to each other as well. Here, talk to each other as you guys go through it. Talk to the person next to you. And see if you guys agree with each one and why you guys agree with each one.
Wait,
What do you think the first one?
that goes highly. Oh.
Fourth one. You're in
I'm trying to, so close on.
See?
Negative.
That's a negative one.
Oh, negative 3. Or no, because it's in
Oh, yeah.
one of the
Yeah.
right.
Well, one time they're not his camera. Cosine of that.
So, most accessible. I will.
I don't think X is here. No, I don't like that. So people think that there. This is a lot. That would be.
Oh, there, resistance.
Right. Be honest. I go one.
I'm gonna bug people as we go. Good.
As with equal with this happening. Not that you lose it. Just. So it's just so it would be less. So you hold everything as the other positive is easy iron. Wait, I mean iron is negative, but what's an inverse two materials? Keep reading that. Ratio is the cosine versus zero is cosine versus that.
It's
Oh,
all
you're negative.
I didn't answer. I just
Yeah.
short.
Your brain just.
No.
Just leaving.
That's wrong with the boat.
Let me see. Who can bug? Who can bug? So I'm gonna bug the pairs of people. We good? Since you guys are all sitting in pairs. So cosine inverse of -1. Will and Sam.
Oh, negative 1.5.
Hi, we're good. So we are right here. The x value is negative, and the angle measurement that corresponds to an x value of being -1 is pi. Are we good there? Bam. Whew. Number 2, cosine inverse of 0. Anya and Addison. 5/2. Is that right? That's right on top of the unit circle. The angle measurement is 5/2, and then that's the only time you have the x value being 0. Perfect. And the last bunch to bug, sine inverse of -1/2. Gavin Aramis. Either one of you guys. Yeah, either one of you guys can answer.
2 pi over 3.
Perfecto, right? That's gonna be quadrant 2 because it's negative, right? And the angle measure that corresponds to that. Okay, we good. Raise your hand. Thumbs up if everybody got all of them right. Cool. Okay, and of course, one more. Instead of having sine inverse, if you say arc cosine, you're saying the same thing. Arc, it just means inverse. Arc is inverse. So give me the angle measurement in radians. Yeah. So arctangent or tangent inverse, that means the exact same thing. I think that's where we left off, right? Right before this right here.
Yeah.
It's when the times.
Oh. I was teachers.
So because it's a positive 1/2, we are in quadrant 1. Is that right? We're looking for x value that's quadrant 1, and then we're looking for the angle value that measures it in radians, which is pi over 3. Are we good? Perfect. And thank you so much, guys. There's quite a few of you guys that talked to your neighbor about it. That's awesome. Exactly what we're supposed to be doing. Okay, tangent, here we go. Which we are trying to figure out how to break this up so that we pass the horizontal line test for tangent. What do we do?
Just
cut off the side ones. Lila says, I agree. Cut off this one, cut off this one. Does it pass a horizontal line test now? Yes. Perfecto. Now, a few little things here.
That's noise, cut off the whole thing.
It has to pass eventually. You're going to eventually get things, right? Even if you're like this. Good question here. Even if you're x squared, right? Remember we talked about this last time here, like this? If that's x squared, can you still cut it off so you pass a horizontal line test? Yeah. You just cut off One of them. So eventually you just keep on cutting until you finally pass the horizontal line.
Would you cut it up too much?
Yes, so that's why you want to be right. You could have cut it off like this, but then you don't get the full graph. Like if you do it like this, then you're like, oh shucks, that's too much, right? So yeah, you cut off too much. Okay. So if this works here, let's see, quadrant one. Does that works in quadrant one? Because we're from 0 to pi over 2. Now notice real quick here, at pi over 2, we don't have a value, right? So it's not including pi over 2 because tangent, there's never a value for tangent of pi over 2. Ooh, we go backwards now from 0 to negative pi over 2. That is quadrant 4, right? But it's quadrant 4's evil negative twin. We good? Evil negative twin. Or just negative twin. What would you guys say? Evil negative twin or just evil twin? Or just negative twin?
Evil twin.
Just evil.
Just, no, it has to be negative though. Okay, so there it is. So when we do this, we look at quadrants 1 and 4, right? With the negation of 4. All right, let's go with it. Do, 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 do. All right, evaluate the function, and I think this is where we left off last time. Is that right? This is the last one. Because I have all my notes here. Okay, boom. Oof, okay. We passed that or no?
No.
What? My notes, I think this was the last we ever did that. Oh, okay. Okay, gotcha. So let me do this here. Keep. I'm going to get rid of this. And I'm going to go with graph. Okay, here's where we left off. Let's go with it. At least I think. Exercise 5. Evaluate the function. I need arc tangent of root 3. It'll be good to sort of go over it again as well. I think we did this one pretty sure. I don't think we did B though. That's the thing. Okay. Sweet. Okay, this is in radians, so kind of be careful there.
What's tangent? Is that 5 or 6? Or X? What's
How do we do tangent? Tangent is done a little differently because tangent needs an X and a Y pair always.
yeah.
So in this case, what you do is you take this little root 3 and you always make a fraction out of it. We good? So we're looking for this. And then notice on our unit circle, except for ones and zeros, all of them have a denominator of 2. Is that right? So here's what we're going to do. We're going to build this up. We put a 1 underneath. And then what we do is we make this guy into this. We put a denominator of 2. And anybody help me out here. Tangent, is it x over y or y over x?
Okay.
It's y over x. I'm looking for a y value. So now we're looking for both. For tangent, we look for both. I'm looking for a y value of root 3 over 2, and x value of 1/2. Where is that?
Pi over 3.
Pi over 3 is true and correct. Boom, boom, boom.
Did you just divide both sides by 2?
You stick in a 2. Yeah.
Yeah.
So, what would the new letter look like?
Yeah, because the reason for it is because our unit circle, notice what we do. Our unit circle looks like this. Notice all these 2's over here. There's a 2 there, there's 2's there, right? Besides, whenever you have a coordinate of 1 and 0, right? Besides those, or negative 1 and 0, you always have a denominator of 2. So then what we do is we just build it backwards. So we say to ourselves, okay, if that's true, and this is root 3, it's just a root 3 just sitting there, right? I'm going to build it up so it looks just like my coordinates. So I make a 1 underneath it. And then I put a denominator of 2 each time. So I'm just using like arithmetic in reverse. Is that right? Because the other way I would do it, I would cancel denominators, right? 2's, and then I would get a root 3. Okay. B. I think I'm going to write B over here. B. B is tangent inverse of negative 1. Where's that at? Now that one's a sneaky one. This one, you do have to understand that whenever you have numbers of the same top and bottom, you technically have a 1 on your hands, right? So this one's a sneaky one. Let's look at our unit circle. Because you have a negative, which quadrant are we in? No.
4.
4. It's the evil negative twin. 4, right? So I'm looking here. Perfect. So how do you get a negative 1? What's the ratio of each one of these guys being a negative 1?
square root 2. Wait, no. Negative square root 2/2.
Perfect. Let's do this, guys. On our unit circle, is that right? For tangent, let's kind of move this out. Let's do like a tangent real quick here. So this is -1/2, right? This is this is y over x. Is that true? If the twos get canceled, I'm left with this right here. Are we good? We just made a tangent. We good? We just made a tangent value here. For -√2/2 over a positive √2/2, what happens here? -√2/2 over a √2/2. That's going to be -1. That's the one we're looking for. We good? And this is the one that we did before, I believe. This is a -√3/2 over 1/2. The twos are gone. Is that right? I'm left with a √3. So if you want to make like a tangent column, right? You can make a tangent column there. And then you can also do it in quadrant 1. But yeah, we're looking for this guy. And that value is
-π/4.
-π/4, because we're looking at the negative evil twin of quadrant 4. Oof. So how about a -π/4? Are we good? Too good, too good. Okay. Boom. Let's switch to. Are we good there? Sweet. Zhunka. Exercise 6. Evaluate the function in degrees this time. That's all. In degrees. Give me that. And give me this one. All right. And again, talk with the person next to you just to make sure you guys have the same answer.
No, we're trying to make for negative. So I think we want to make that this
Those who are
actually
Yes.
not 150 is 0.
So.
Yes.
Or is it?
You want to look at the foods but
Tangent is the.
yeah. So this is the y that they this here. Yeah, we're gonna do it negative as well.
Oh, okay.
So
And then the lose. It is.
yeah, yeah.
But- How would you?
No, -5%. So it's supposed to be negative.
Oh.
Remember, this is in degrees, right? You want to give me
Oh,
degree
sorry.
values. Give me degree values.
Negative 30.
It's the.
150. This is not.
It's on my arm.
We don't.
I think it's 150. I'm just so used to doing like I was just so used to doing radians.
Radians, Hey, when you guys get to calculus class, you guys will just be doing radians for the most part. Oh, sorry. First bubble there.
And we're changing to
All right, here it is. So let's see. Let me pick on people. We good? Pick on people. Lila Jaya. Hold on, I want A.
Oh.
And then we are in degrees. We didn't do it. Okay. Pick on some other two people.
oh
Lucas, Natalie, what did you guys get for A? It is in degrees. Is that right?
radians.
Is in degrees? It says about the function degrees, right?
I can go to degree. No. Oh yeah.
Last one was in radians. This one is in degrees.
We know
So.
We are looking for quadrant 4. We're looking for that little guy right there, right? We're looking for a √3 in the bottom. And the only way that happens is this right here. And how about a -30 degrees? Come on. We're good there. Sweet. Okay. Now, Lila.
Yeah.
Arctangent of 0 is? No. No.
Wait, Pat, what? Put the other one.
But it's.
Let's look at it here. So by definition, sine inverse is y value over x value.
Oh, it.
I need it in degrees. And then I need a y value of, let's see, how do you make 0? 0 is made by
Whatever this.
y for 0 and a 1 for x. Is that right?
What divided by?
Otherwise, if you flip it the other way, it'll be undefined, right? That's not cool. So, Lila and Jai, tell me, when do you guys have x value of 1, y value of 0?
At 0.
Perfecto. 0 degrees it is. Okay. Dun, 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 dun. Okay, now, if you have your calculators with you, please take them out. And if you have them out, please turn them on.
And if they're on.
And if they're on, let's go to whatever mode I want you to put you in. So I can put you into radian mode. I can put you in degree mode. We good? And I can switch it up to whichever mode I want you to do it in. We good? All right, let's jam here. So here it is. I will say ahead of time, real quick here. Here's what we're gonna do. Your calculator is kind of funny. It will calculate the inverse function because there's functions inside that. We're good. Just note that when you go into like, well, let's go. So let's go with it here. So if you guys can tell me, evaluate the function to the nearest 10th of a degree. So what mode are you going to in?
Yeah.
Good. Yes. All right. You go to the mode button and you press degrees if you want to get the right answer. But if you want to get the wrong answer, what you do is you press radian mode. Okay, I need that guy.
48 points. Degrees.
Perfect. Okay. So again, I need the person next to you to make sure that you guys.
People sweat. That's true. You get the right thing. What's that?
I don't know how it's to know if it's charged.
All right. All right. You guys talk to each other. Make sure you guys help each other out in order to get. I think it was anybody. What is the degree?
48.2 degrees.
48.2. Everybody got a 48.2. And if you have only one calculator between you guys, if you guys can have one person do it, the other person do it. Just kind of real quick here. All right. If you have two calculators, that's cool. Good sharing. Sharing is caring. All right. Cool. We got a 48.2 is true. Calculator's so much easier to do it with calculator, huh?
Yeah.
Okay. Let's see if I change it up. Nope, this is still degrees. And go. Next one. Where are we at here? Cosine of negative 0.88. Now, the answer should be in quadrant 2, right? The degree value should be between 90 and 180, right? That's kind of what you should kind of think through. And the answer is...
No, that's not right.
I heard 150.
1.
1.
No, it was 1
point
4.
6 is good. We good?
You want 1 decimal.
1 decimal place. So nearest 10th of a degree. Nearest 10th of a degree. You guys good? Share calculators if you need to. Maybe one person does one person the other. You good there? Just to try it. Just so you guys to try it. All right, and the next one. Tangent inverse of this guy. All yours there.
Reading 6 weeks? What do you get the answer?
Oh, I didn't even get that. Negative 1.3. At the same thing.
Yeah, that's right.
Okay, we good? Answer is
Negative 11.3.
all right. Negative 11.3 should be it. So that's cool. So your calculator. Yeah, so you guys good there with that? All right. So let's do a few things here now. Let's do some algebra. with this stuff. So here's what I want to do. I'm going to set up an equation. I'm going to say what to plug in for x, and then you have to work out the equation. Good. So without a calculator this time. That the calculator part. Whoa! Don't break your calculator. Just put them away. So back to unit circle. Back to unit circle. Here's what I want you guys to do. Can you guys simplify this equation right here?
What?
Oh,
A certain condition is met if, whoa, that should be a pi. What's up with that? That's weird.
absolute value.
Absolute value.
Yep, that is absolute value there. So we're gonna plug stuff in. Oh, this is x. Sorry. What? Sorry, guys. Copying. X is right here. So not pi over 4. It is x. Whoa, that is weird.
Wait, absolute value?
Absolute value. So it's 3 absolute value cosine of theta. But then theta is cosine inverse of x over 4. That is weird. So let's do it together. We can do it.
I can replace that in there.
Yes. So let's replace that in there first. So we're going to go 3 cosine of cosine inverse of x over 4. Oh boy.
I'm so.
So we're all not.
We're supposed to do this with a calculator?
Yeah, because you don't know what x is, right? Oh, and then absolute value marker. I forgot that one. Where are we at? We good there?
Three, the absolute value. 3 times the absolute value of x over 4.
Yeah.
When the cosine was just cool.
Absolutely. That's what we're trying to do here. So here we go. Guys, are you ready for this? If you're taking the trig function of the inverse trig function, what happens? These guys are gone. They disappear from each other. Because that is what cosine inverse is all about. We good? Now, we don't know what x is. X could be positive or x could be negative. We don't know, right? So we have to keep the x inside the absolute value. But a 4, isn't 4 positive?
Yes.
Yeah, okay. So
Well,
we can,
value.
whoa, we can move the 4 out, but it's in our denominator. Is that right? So it's 3/4 multiplying the square root of x. Absolute value of x. We just don't know what x is. We got to keep it inside the absolute value because we don't know if it's negative or positive. We good? So we keep it there. Are we good? But that is it. We good? We keep it right there because we don't know what x is. We didn't say x is 12 or x is 24, or x is negative 62, right? We didn't know. So we keep it there. We're good? That's the algebra act of it. Okay, now let's work a little bit more on this because there's a little bit of nuance, guys, we have to understand right here. This is important. If you are taking the trig function of an inverse, they cancel right away. We good? The other way is not true. Okay, so let's talk about it as we go. We're going to go through some of these here.
Okay.
All right, so let's do the easy ones first, and then we'll move on to a little bit more complicated. They do get a little bit more complicated. We're good, just so we know.
Oh.
So evaluate this without a calculator. I need sine inverse of 3/4 or 3/5.
3/5.
So these
I
can.
think I am.
Taking a trig function of a inverse trig function. Da, 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 da. The only thing we got to think about is this. I guess we should think of this here. Yep. Is this a ratio that makes sense for sine? Is 3/5? Is that possible to have a 3/5 ratio for sine?
No.
Ooh, hold on.
Wait.
Let's see. Yeah. Let's see. What's the highest sine can go?
1.
1. What's the lowest sine can go?
0.
-1, right?
-1.
So is 3/5 between the zone of -1 and 1? Yes. If it is, Cancel, cancel, and the answer is 5/3. We good?
3/5.
As long as it's inside the zone of sine, which is -1 to 1. Okay. Let's go another one here. How about this one? Sine of sine inverse of -4/5. Is it inside the zone for sine? In the zone. If it does, cancel, cancel. I'll let you guys copy down the problem first, though, of course.
We're figuring. I feel like that's more than itself.
And the answer is
Yeah.
-4/5 is good, good. Okay. Let's keep on going. So if you want to put anything off to the side here, right, kind of go like this. This has to be from -1 to 1. Good. That little guy.
Wait, so what if it's not? Is it just like undefined? Like this?
Yeah, so let's see. What we're trying to do is this, right? We're trying to figure out, let's see if this makes sense here. Our sine curve goes like this, from -π/2 to π/2, right? It starts here, and it goes like that, right? So the highest this guy can be is -1. Oh, sorry, the lowest and the highest is that right here, right? So we just said like, hey, when this guy is 3/5, do we have a value there? Yeah, we can get to the value. If it is -4/5, do we have a value there? Yeah, absolutely. Oh, sorry, going the other way. Sorry. I am, because we're going inverse function here. The 3/5 is this way here, so it's the y values that we're looking at. So right here. So can I get to graph from 3/5?
Mhm.
Yeah, boom, and then that was my value. Can I get to the graph from -4/5? Yeah, we good. So it's about the graph when we're able to get there. Okay, yours here.
Uh-oh. Nope, keep it.
And do it. It's not inside the zone for sine, right? The zone for sine is from -1 to 1. So there is no answer, not possible, whatever, however you want to answer it. We're good?
Fine.
Because this guy has to be between -1 and 1. Okay, let's go the other way now. So for these guys, for the sine of sine inverse, it has to be between -1 and 1, or else it just does not work. We good? For cosine is the same way, from -1 to 1. For tangent, we don't care, because tangent can go from -infinity to +infinity, right? It's just for sine and cosine because they're special, because they oscillate, right? They go up and down, up and down. That's all. That's why. That's why it's makes sense. Okay, let's go the other way. So if that's true, good catch. Then we go like this. If we go the other way, what do we need to be careful for? And if you want to write this in, this guy has to be between -π/2 and π/2. Are we good? Remember, those were our conditions for sine inverse. Remember that. Remember, it's the evil twin in quadrant 4. Is that right? Up to quadrant 1. So, is π/4 between -π/2 and π/2? Absolutely. These guys can cancel each other out.
Wait, you said you.
You can't necessarily.
No, we're going to have the conditions. So the condition for this one to cancel is -1 to 1. And the condition for this one to cancel is -π/2 to π/2. So you just have to be a condition on it.
It
Okay.
doesn't matter which way the sine is, as long as it's within that range.
Mm-hmm. Now, real quick here for these guys, and you got to be careful. I know it's just notation here. So for these guys, there's no answer. Once this guy goes outside of this range, there is no answer anymore. We good? The next one, let's think about it. This is the heavy one here. Ready? E, D. Hold on 1 second here. I'm off by my little chart here. D, E. Okay, I got you. Yeah, this one is a weird one. Are you guys ready? E. Once we get to E, let me go forward here. And we're going to use the unit circle for this. We good? So let me see if I can use the unit circle for the other one here. Okay, but let's go with it. So if you look at your unit circle for this, is this guy between negative pi over 2 to pi over 2? No, okay. But because it's the inverse sine of sine, we can still get an answer here. So let's kind of think through this here whole thing. If I look at the unit circle on your chart, the sine value of 5 pi over 4 is where? It is. Is it in quadrant 3? It's right down here. Is that right? Right here? Okay, think with me here for a little bit. Ready? And we'll do it both ways here. We'll do it the quick way and then we'll do it the slow way here. So this is the y value, but here it is. Sine inverse only operates where again? 1 and evil -4. Is that right? It in quadrant 4, but it's the -4, right? So here it is. What's the y value right here? This is a root 2 over 2 or negative root 2 over 2. Is that right? This is another negative root 2 over 2. Is that right? So if I were to, what we say is move this over, right? So it's inside this area right here. I need to bring it back into quadrants 1 and 4, or actually 1 and -4, right? But the y value has to stay the same because sine has to stay the same. Are we good there? So what is this one? And it's called mapping, basically, mapping or reflection. So this is a positive root 2 over 2 over a negative root 2 over 2. Do you notice that the y value is still the same? Is that right? So according to sine inverse, what is this angle measurement according to the sine inverse function, which is quadrant 1 and evil negative quadrant 4? Okay, negative quadrant 4. So if you look on your unit circle, tell me if this makes sense as I put down the answer. So we go back to quadrant 4, the negative quadrant 4, right? We just have to make sure that our y value stays exactly the same. Our y values did not change. So we call this mapping. We map all the dots here back into quadrants 1 or 4. We're good? Cool. But any questions? Go ahead with the questions. Sure. So let's go with it here. So let's do it the long way now. Tell me, what is the sine value of 5 pi over 4?
Negative
-2 pi over 2.
Okay, so notice what I did is by algebra or by pre-algebra, I have done that. We're good? I've simplified sine of 5 pi over 4. It is negative root 2 over 2. Now the question is, what's the sine inverse of negative root 2 over 2?
Okay.
So notice all we did is just doing the value as we go. We're good?
This is simplifications.
Okay, are we good? So here's the rule. The rule is if this was between negative pi over 2 to pi over 2, we could have just canceled these out and put the answer. We good? If it's not between negative pi over 2 and pi over 2, then we have to go back to our unit circle and we have to map it back to the place where the sine inverse works, which is quadrant 1 and quadrant -4. Okay, we're good. Let's practice a little bit more on these and I'll kind of intersperse them. We're good? Because it's kind of... So just for you guys, just a recap real quick here, because I know this is kind of heavy. So if you have the inverse sine function of your sine function, we can always get answers. We good? But if it's the other way,
So
if it's sine or sine inverse of or sine of sine inverse of something other than 1 and -1, like 2.5, there is no answer. We good?
So
because there's no way to get up to 2.5 on a graph.
So if it was cosine instead of sine, there would be no answer for this one. Because the x values don't match.
Oh, there still should be the same answer. Yeah. So let's do that.
Yeah.
Okay, Lucas brought a point here. What happens if it was, let me kind of put this like E, I have an F down here already here. So let's just put extra. Go put extra. So cosine inverse of cosine of 5 pi over 4. Let's do that one because that might just make sense here. Where does cosine inverse work? Which quadrants?
1, 2.
Okay, so cosine inverse, this function right here, works in quadrants 1 and 2. So this guy and this guy. Question, is 5 pi over 4 inside quadrant 1 and 2? No, it is in quadrant 4, which is down here. The cosine value is x or y. Which one is it? X. So this is negative root 2 over 2. So we want to make sure this dot goes back into quadrants 1 or 2 so that the x coordinate is exactly the same.
Oh.
So where could I plot the point? So it's in quadrants 1 and 2. I don't care about the y value. Who cares about the y value? Because it is not part of cosine. Perfect. So all we do is now is we move it straight up. We move it to here. The cosine value is exactly the same, or the x value is exactly the same. We don't care about the y value. That's all I'm important of. And the question is, what is this angle measurement here? And we heard it to be 3 pi over 4. Answer is 3 pi over 4. Are we good? Makes sense. Light bulb turned on. Love it. Okay. Now let's do the other ones real quick here then. Now that we got that taken care of, now we can move fast. On your mark. Get set. Go. I need cosine inverse of 1/2. Question is, can I cancel it or okay? Oh, hold on. I flipped it on you guys, right? This is now the trig function into the inverse function, right? So now we say this. Is this guy between -1 and 1? Yes. If it is, what can we do? Cancel, cancel. We are left with 1/2 easily. G.
No.
G is this one right here. Answer.
Wait, it's upside 1.
Oh, yeah.
Map again.
No, can't map on this one. We don't map
Oh.
if it's trig of inverse. The answer is just no answer.
Okay.
We're good? It is
If
not.
it's the other way.
If it's the other way, you still get answers.
Okay.
If it's this way, you don't. Okay. And then let me flip it the other way now. Boom, 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 boom. Let me flip it this way now. What do you guys say here? I got 5 minutes left, guys, and we got to do a couple more things here. So if you guys can put your thinking caps on just for a bit, we'll go with it here. So cosine inverse of cosine of 3 pi over 4.
Cosine of
Negative 2 over 2, but then cosine inverse of negative 2 over 2 would be. Hold on, is this inside our? Yes, it is inside our.
negative what? Wow. It just
Cancels. How come? Because it is inside from 0 to pi for our inverse function, right? So this guy here, if you guys kind of think about it, this guy here on the outside kind of controls the domain here, controls everything else. We good?
Sorry. So
Cosine of 3 pi over 4 would give you a negative root 2 over 2.
I have the range. I would be 2.
Oh no, for cosine. For cosine, it's 0 to pi. Right? It works in quadrants 1 and 2. That's
And sine 5.
Sine is from negative pi over 2. Okay, are we good? That's all fine and dandy until we get to things we don't know. So I'm going to skip just for time's sake. Oh, no, we could do this one. Oh, okay. All right, all yours here.
Oh, wait.
Okay, guys, let's see. We got shucks. I didn't get to the last thing here. Okay. I'd rather do it slower than fast and kind of confuse you guys here. So all yours here. Question is this within the range for no? Hey, I think we did this one before, didn't we?
Yeah.
Yeah, that's right.
We did this one with the example.
This one here, boom, boom, boom. We got to move it up into quadrants 1 and 2, and the answer is 3 pi over 4. We got
The future.
that is so cool. Lucas predicted the future. Okay. So now notice so far we had the trig function and its inverse, right? Ooh, switch it up on you guys. Ready? What happens if I take a trig function and another trig function? What craziness? Okay.
Well, wait. Wait, cliffhanger. Cosine or sine over cosine.
Sine
So
over
then you
cosine.
cancel out the cosines, and then
You'll be slow left with sines.
first side 3 and 4. Yeah, no.
What did you get?
With time sine 3 over 4 is
Oh, okay. Sam, you try it your way. Let's go for it here. So, tangent inverse, is the value positive or negative? Oh, I want the exact value. And that's not it, I don't think. So notice the 3/4, it's positive, is that right?
yeah.
If tangent inverse is positive, which quadrant are we in? We're in quadrant 1. Are we good? So we're going to build our little thingamajiggy, and we're going to build a little triangle, and we're going to say the x value is 3, y value is, or sorry, 4, right? X value is 3, or we can just say opposite and adjacent here. So we build a triangle. We good? We gotta go back to triangle. Because it's not tangent, it's tangent inverse. I guess maybe that's the issue.
Couldn't you just do inverse sine over inverse cosine? Because
Let's see. It'll give you the same ratio. You're still doing cosine inverse. You're still doing sine inverse of 3/4 over.
what? And then we can cancel the cosine. I'll be scared of it. No.
I'm gonna see that. That's kind of cool, Sam. That's actually kind of thing. I think you should be able to do so, but then you still need to make this chart for it, though. You're still stuck with a chart because you're still gonna have to make an inverse of sine inverse of. That's cool. I'm gonna check on that. So you guys ready? This is a 3, 4, 5 triangle, is that right?
Yes.
Perfect. And cosine is defined to be what? The x coordinate over the r coordinate, is that right? What is the x coordinate here?
4.
4. What is the r value? 5. So notice it is a little bit different. Sorry, class. We're not done yet. We just have a little tiny bit to go with 4.7. We good? I still want to do the test on Friday of next week, but we are going to just do like one little extra piece on Wednesday. We good? That will take test Friday. I'm going to let you guys go right now because you guys only have 5 minutes to get to period 3.
Hurry.
Uh-huh.
Man, let's do a pre-period.
Let's have a period. That's true. So true.
Who's excited until mine?
All right, guys, enjoy your phone on let's see. There's lunch, and then there's what? There's a
What's
what's the activity for lunch? Anybody know?
snowball fight?
Snowball fight. Okay, gotcha.
Pretty much the dodgeball with snowballs.
Yes, that's correct. Yeah. Slow dog ball. Uh-huh.
Thanks, Project.
You are welcome, guys.
Oh, no.